अलजेब्रा ऑफ लिमिट्स। अब लिमिट के बारे में कुछ रूल है, देखो। इफ f and g be two functions with a domain n, common domain है, we define four functions f plus g, f minus g, f into g and f by g on n by setting f plus g xy is equal to fxy plus gxy, f minus gxy is equal to fxy minus gxy, f into g xy is equal to fxy into gxy, and f by g xy is equal to fxy by gxy if this gxy is not 0 for xy in this domain n। तो इस रूल का हम लोग यूज करेंगे। नाउ थ्योरम, ये रूल वही है जो सिंगल वेरिएबल के केस में था। If fg be two functions defined on some neighborhood of a point ab such that limit fxy is L and limit gxy is equal to M when xy tends to AB, then first limit f plus g is equal to limit f plus limit g, this is equal to L plus M. Limit f minus g is equal to limit f minus limit g, this is equal to L minus M. Limit f into g is equal to limit f into limit g, this is equal to L into M. And limit f by g is equal to limit f by limit g, this is equal to 1 by M, provided M is not 0 when xy tends to AB। तो जैसे सिंगल वेरिएबल के केस में था, सेम वही रिजल्ट यहाँ भी है। अब इस पे एक एग्जांपल हम लोग देख लें, उससे आइडिया क्लियर हो जाएगा। प्रूव दैट लिमिट xy टेंडिंग टू 1 to x स्क्वायर प्लस 2y इज इक्वल टू 5। इस तरह का प्रॉब्लम आता है करने के लिए। तो मेथड 1 पहला मेथड है कि यूजिंग डेफिनेशन ऑफ लिमिट, लिमिट के डेफिनेशन को यूज करके we have to show that for any epsilon greater than 0 we can find delta greater than 0 such that mod x square plus 2y minus 5, this 5 is this one, is less than epsilon when x minus 1, this one is here, less than delta, and y minus 2, this 2 is here, less than delta। तो तब हम कहेंगे कि ये जो फंक्शन है x square plus 2y, this function has a limit 5 when these two conditions hold true। अब देखें, if mod x minus 1 less than delta and mod y minus 2 less than delta, then since mod x minus 1 less than delta का मतलब हुआ 1 minus delta less than x less than 1 plus delta, यानी x की वैल्यू 1 minus delta और 1 plus delta के बीच में है। Similarly, y minus 2 less than delta, modulus of this one, it means 2 minus delta less than y less than 2 plus delta, excluding x is equal to 1 and y is equal to 2 because there is no equality, so x and y both are excluded। Thus 1 minus 2 delta plus delta square make square of this one and this one, so 1 minus 2 delta, 1 minus delta whole square means 1 minus 2 delta plus delta square, this is your x square, it is less than 1 plus 2 delta plus delta square। Similarly, we will square this one and get 4 minus 2 delta less than 2y less than 4 plus 2 delta, so add these two, then you will get 5 minus 4 delta plus delta square less than x square plus 2y less than 5 plus 4 delta plus delta square। We don't square this y1, why? Because we need only x square plus 2y, square in x not in y। So minus 4 delta plus delta square less than x square plus 2y minus 5 को ऐड कर देना है, less than 4 delta plus delta square। Now if delta is less than or equal to 1, it follows that minus 5 delta will be less than x square plus 2y minus 5, which is less than 5 delta। Since here delta is less than or equal to 1, so this will be less than 5 delta and this will be greater than minus 5 delta, so this inequality comes, that is mod x square plus 2y minus 5 is less than 5 delta। Suppose this is your epsilon, so delta will be given as epsilon by 5, or we will take delta equal to 1 whichever is smaller, because delta is less than or equal to 1, तो हम लोग delta equal to 1 भी ले सकते हैं, but जो स्मॉलर होगा इन दोनों में से, इसमें epsilon by 5 और 1 में से। Therefore, mod x square plus 2y minus 5 is less than epsilon when mod x minus 1 less than delta and mod y minus 2 less than delta. So limit x square plus 2y xy tending to 1 2 is equal to 5. ये हमारा सॉल्व हो गया. अब मेथड 2 दूसरा जिसके लिए कि हम लोग को वो थ्योरम का यूज करेंगे. Using above theorem on algebra of limits, limit xy tends to 1 to x square plus 2y is equal to limit xy tends to 1 to x square plus limit xy tends to 1 to 2y. ये f plus g xy का रूल हम लोग लगा रहे हैं यहाँ पर. So this is only x square, so we'll substitute x is equal to 1, so this is 1, and plus this is only y 2y, we will substitute y is equal to 2, so this is 2 into means 4, so 1 plus 4 is equal to 5. So by the theorem we also get the same result. तो ये problem solve हो गया. Similarly there are some other problem for your practice. 1 2 3 4 1 2. There are some other problem. You can solve them yourself. This is solution is also given here. अच्छा, यहाँ हो गया, इतना एग्जाम्पल हो गया, प्रॉब्लम हो गया. फिर नेक्स्ट हम लोग आ जाते हैं एक और कॉन्सेप्ट देख लो, रिपीटेड लिमिट का. इफ ए फंक्शन f is defined in some neighborhood of ab, then the limit y tends to be fxy if it exists is a function of x. क्योंकि y tends to be है तो ये जो लिमिट होगा it will be a function of x. Suppose it is phi x. If then the limit x tending to a phi x exists and is equal to lambda, we write limit x tending to a limit y tending to be fxy is equal to lambda, and say that lambda is a repeated limit of f as y tends to be x tends to a. क्योंकि lambda इसी फंक्शन को दो बार लिमिट लिया गया, first y tends to be and then x tends to a. That is why we call it a repeated limit. If we change the order of taking the limits, we get the other repeated limit. Means limit y tends to be limit x tends to fxy is equal to lambda dash. यानी इसमें x tending to a पहले ले लिए, बाद में y tending to b. When first x tends to and then y tends to b, these two limits may or may not be equal. ऐसा भी केस है कि फंक्शन है जिसमें कि both these limits are not equal. Note है, in case the simultaneous limit exists, these two repeated limits, if they exist, are necessarily equal. अगर simultaneous limit exist कर रहा है तो ये दोनों limit means lambda and lambda dash both are equal, but the converse is not true. However, if the repeated limits are not equal, the simultaneous limit cannot exist. एक example इस पे देख लोगे तो idea ठीक हो जाएगा. Let fxy is xy by x square plus y square. Then limit y tends to 0, limit x tends to fxy is equal to limit y tends to 0. और इसमें x tending to 0 अगर लिखेंगे, so this will be 0. It means it is 0. So limit of 0 is 0. Similarly, limit x tends to 0, limit y tends to 0, fxy is equal to 0. Because y tending to 0, this will be 0 and limit of 0 is 0. Thus, a repeated limit exists and are equal, but the simultaneous limit does not exist, which may be seen by putting y is equal to mx. जब हम लोग पीछे एक एग्जांपल किए थे इस तरह का कि ये जो फंक्शन है इसमें साइमल्टेनियस लिमिट एग्जिस्ट नहीं कर रहा है along any line y is equal to mx. तो डिपेंडिंग ऑन दिस लिमिट डिपेंड्स ऑन m, और m पे अगर डिपेंडेंट हो गया तो कहेंगे लिमिट डज नॉट एग्जिस्ट. एक और एग्जांपल है, fxy is y minus x by y plus x into 1 plus x by 1 plus y. Then limit x tending to 0, limit y tending to 0, fxy is equal to limit, पहले y tending to 0 ले लो, limit x tending to 0, y tending to 0 लेंगे तो ये minus x by x means minus 1 हो गया, and this is 1 plus x by 1, so it is minus 1 plus x by 1. x tending to 0 लेंगे, this will be minus 1. And limit y tends to 0, limit x tends to 0 fxy, पहले x tending to 0 ले लेंगे, this is equal to limit y tending to 0, x tending to 0 लेंगे तो this will be y by y means 1 into 1 by 1 plus y. अब y tending to 0 की, this is equal to 1. So these two repeated limits, they are not equal. Thus the two repeated limits exist but are unequal. Consequently, the simultaneous limit cannot exist, which may be verified by putting y is equal to mx. y is equal to mx से भी हम चेक कर सकते हैं ये जो लिमिट है, this limit depends on the values of y, which is not a unique one. So the simultaneous limit does not exist. इसके बाद कुछ और एग्जाम्पल हैं, तो उनको हम लोग कभी देखने का नहीं है, आगे बढ़ते हैं। नेक्स्ट इज योर कंटिन्यूटी। कंटिन्यूटी का कॉन्सेप्ट है, a function f is said to be continuous at a point ab of its domain of definition if limit xy tending to ab fxy is equal to fab। यानी कि जो लिमिट है वो इक्वल टू हो जाएगा वैल्यू ऑफ द फंक्शन, लिमिट इक्वल टू वैल्यू ऑफ द फंक्शन। दिस इज फॉर कंटिन्यूटी। In other words, a function f is said to be continuous at a point ab of its domain of definition if for epsilon greater than 0 there exists a neighborhood n of ab such that mod of xy minus fab less than epsilon for all xy in n। ये हो गया हमारा कंटिन्यूटी का डेफिनेशन। The definition of continuity of a function f at a point ab requires that besides ab, f is defined in a certain neighborhood of ab, and moreover the limit of f when xy tending to ab exists and equals the value of ab। यानी कि जो लिमिट है वो वैल्यू ऑफ द ab के बराबर हो जाएगा। A function which is not continuous at a point is said to be discontinuous। अगर कंटिन्यूअस नहीं है तो कह देंगे सिंपली दैट फंक्शन इज डिसकंटिन्यूअस। एक एग्जांपल इस तरह का हमारे पास है, investigate the continuity at 0 0 of the function fxy equal to x square minus y square by x square plus y square when xy is not 0 0 and it is 0 when xy is equal to 0 0। तो इस फंक्शन की कंटिन्यूटी चेक करनी है 0 0 पर। देखें इसको भी, since limit xy tending to 0 fxy does not exist, therefore the function is not continuous at 0 0। देखो ये जो फंक्शन हमारा है, this function if we find the limit along y is equal to mx, so this will be x square minus m square x square by x square plus m square x square, so it means 1 minus m square by 1 plus m square। यानी कि यह जो लिमिट हमारा निकलेगा that will be depending on the values of y। So if you substitute m is equal to 1, you will get one value. If you substitute m is equal to 2, you will get another value. So one will not get a unique value for the limit, and hence the limit does not exist, and so the function is not continuous at 0 0। तो सिंपल है। इसके बाद एक और देख लेते हैं, investigate for continuity at 1 2 fxy is equal to x square plus 2y when xy is not 1 2 and it is 0 when xy equal to 1 2। Here limit fxy xy tending to 1 2 is equal to 5। ये हम लोग पीछे एग्जांपल में देख लिए हैं कि इसका लिमिट आता है 5, बट दिस इज नॉट इक्वल टू f12 बिकॉज f12 इज 0। f12 हमारा 0, ये f12 के बराबर नहीं है। It means limit of the function is not equal to value of the function, so this function is not continuous at 1 2। Hence the function is not continuous at 1 2। This point 1 2 is a point of discontinuity of the function। However, if the function had the value 5 at 1 2, it was then continuous at the point। अगर यहाँ 0 की जगह 5 कर दिया जाएगा तो ये जो फंक्शन है it will be continuous at the point 1 2। और इस तरह के discontinuity को हम लोग बोलते हैं removable discontinuity। If as in the above example it is possible to so redefine the value of the function at a point of discontinuity that the new function is continuous, we say that the point is a removable discontinuity of the original function। अगर यहाँ से 0 हटा के 5 कर देंगे तो ये जो discontinuity है this will be your removable discontinuity। एक एग्जांपल है और तुम्हारे लिए, ठीक है, तो ये एक एग्जांपल तुम लोग के प्रैक्टिस के लिए है। ये तुम्हें इसको प्रैक्टिस कर, नहीं आएगा तो मुझे पूछना। सॉल्यूशन भी है इसमें। कोई क्वेश्चन किसी को अगर पूछने का है तो बोलो मुझे। एनी क्वेश्चन? इसके बाद हम पार्शियल का शुरू करेंगे। कोई क्वेश्चन किसी का है पूछने का?